What's up, you freaking geniuses? So in this video, I'm going to teach you how to write radicals in simplest form, right? So these are all the examples I'm going to go through. Got some just whole numbers over here and some fractions at the end, all right? So let's start with this first one, the square root of 64, something easy. Now, the goal with these is trying to, well, if you're working on a square root, you want to use perfect squares. If you're working on a cube root, you want to use perfect cubes. On a fourth root, you want to use perfect fourth roots, all right? So for example, this 64, there's different ways we can break up 64, right? We can break up 64, I'll just write it on the side over here, as 8 times 8. We could break it down into 2 times 32. We could do 4 times 16. So these are just a few of the ways we could break it down. Which one would we want to choose though? Well, in this case, we're working on a square root, so we want to use perfect squares. So 4 and 16, those just happen to be perfect squares, right? So 64, I want to break down into the square root of 4 times 16. Now, these two numbers that I'm multiplying together under this square root, I can break them out into their own radicals. So I can write it as the square root of 4 times the square root of 16. And this is going to be equal to 2, and this is equal to 4, right? So we have 2 times 4, which is equal to 8. Okay, now the square root of 64, we obviously just knew right off the bat that this is equal to 8, right? But the main thing I want you to focus on is finding perfect squares in this case. And when we work on cube roots, you want to work on finding perfect cubes. And for fourth root, same thing, and so on, okay? So now let's move on to this next one. So the cube root of 135. So we want to break up this 135 into two factors, right? And one of them we want to be a perfect cube. So some perfect cubes, just remember, are 3, 8, 27, 64, and so on, all right? So can we break down 135 using any of these numbers? Well, it looks like we can break it down using 27 because 5 times 27 is equal to 135. So that's how we're going to break it down. So we're going to say 27 times 5, and this is the cube root, right? So again, now we can break these up into their own radicals. So we're going to have the cube root of 27 times the cube root of 5. Again, this is a perfect cube, right? The cube root of 27 is just equal to 3. So then this is equal to 3 times the cube root of 5, right? That would be our answer right here. Okay, the next one is the fourth root of 567. So again, we want to use some perfect fourth roots, right? So a little list of those would be, well, 1 to the fourth is just 1, right? 2 to the fourth is 16, 3 to the fourth is 81, 4 to the fourth is 256, and so on, right? So can we break down 567 using any perfect fourth roots? Well, again, here we can. It's a little hard to see because this is kind of a bigger number, but 81 would actually work, right? So then here we can break this down into the fourth root of 81 times 7, right? 81 times 7 is 567. Okay, so then here we're going to have the fourth root of 81 times the fourth root of 7, and the fourth root of 81 is equal to 3. All right, so then here we're going to have 3 times the fourth root of 7. All right, there's our answer here. And I'm going to make some room so it doesn't get too jumbled up here. Get rid of these and just move these up a little bit. All right, so now let's move on to some fractions because those are fun. So here we have the square root of 3 over 8. Now fractions we can split up into basically their own radicals, one on top and one on the bottom. So this we can split up into the square root of 3 over the square root of 8, okay? Now here is a big problem. You can't have a radical in the denominator, okay? So this square root of 8, we can't have it just like this. We need to multiply it by another square root to turn it into a whole number. Okay, so how do you do that? Well, we're talking about square roots, right? So you want to think of perfect squares. So again, perfect squares are going to be, 1, 4, 9, 16, 25, right? And so on. So can we change 8? Can we multiply something by 8 to get any of these numbers over here? Well, it looks like we can use 16, right? Because 8 fits into 16. How does it fit into 16? Well, you just have to multiply it by 2, right? So here we're going to multiply not just by 2, but by the square root of 2, okay? And whatever you do to one side of a fraction, you have to do to the other, right? So we need to multiply it by the square root of 2 on top as well. Okay, so if we simplify this on top, we have the square root of 3 times the square root of 2, which is just equal to the square root of 3 times 2, which is 6. And then here we have the square root of 8 times the square root of 2, which is equal to the square root of 8 times 2, which is equal to 16. Okay, now we can simplify this. So on top, the square root, that's fine. We can leave that as it is, but on the bottom, the square root of 16 is equal to 4, right? So then our answer right here is the square root of 6 over 4. And I'm gonna move this stuff around a little bit real quick. Boom, all right. So here are our last two problems. Here, again, these are just perfect squares, cubes, fourths, right? So the next one that we have here is the cube root of 7 over 4. So again, we can split these up into their own radicals. So we're going to have the cube root of 7 over the cube root of 4. Okay, now, is 4 a perfect cube? No, it's not, right? So how can we change this denominator, this 4, to turn into a perfect cube? Well, here's our short little list of perfect cubes. Can 4 fit into any of these numbers? Well, it looks like it fit into this one, right? 8. So how can we make it change to an 8? Well, we'd have to multiply it by 2, right? But not just the number 2. It's going to have to be, again, the cube root of 2. And again, whatever we do to the bottom, we also have to do to the top, right? So we're going to multiply by the cube root of 2 up here also. All right, so on top we have the cube root of 7 times the cube root of 2, so that's going to be equal to the cube root of 7 times 2. And on the bottom we have the cube root of 4 times 2. Okay, so then on top we have the cube root of 14 over the cube root of 8. All right, and like we said, this is a perfect cube, right? It's equal to 2. So then here we just have the cube root of 14 over 2, right? There's your answer. All right, this is the last one here. So this is the fourth root of 1296 over 25, okay? So again, we can break it up into the fourth root of 1296 over the fourth root of 25, okay? Now, before trying to turn this denominator into a whole number, one thing we can do is actually simplify the numerator up here, because the fourth root of 1296 is actually equal to just 6. Okay, so here we have 6 over the fourth root of 25. So now that we have it more simplified, this will be a little bit easier. So here again is my little list of perfect fourth roots. 25 is obviously not on this list. So is there anything we can do to 25, any number we can multiply by 25 to get one of these perfect numbers? Well, 25 doesn't go into any of these numbers, right? This is 1 to the 4th, 2 to the 4th, 3 to the 4th, 4 to the 4th. What about 5 to the 4th? Well, 5 to the 4th power is equal to 625. Does 25 fit into 625? Well, yes, it does. It actually fits in there 25 times, okay? So in this case, we're going to multiply the bottom by the fourth root of 25 and the top by the same thing, right? The fourth root of 25. Okay, so then here we're gonna get, well, on top we have 6 times the fourth root of 25. And on the bottom, we have the fourth root of, well, 25 times 25, which is 625. Okay, so if we simplify this one more time, on top we have 6 times the fourth root of 25 over, let's see, the fourth root of 625, which we saw is just equal to 5, right? So then we just have a 5 down here. So then this would be our final answer. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.